Oh my gosh. So let's start over since I didn't have the the screen up. Sorry about that. So make that maybe 24. Okay. There we go. Alright, so I'm going to start over. So, we were talking about, exponents, exponential functions and things. And when we're talking about exponentials, what we're talking about is some number in the exponent place. Okay? So in this case, we have 3 raised to the 4th power, and that equals 81. Alright, that's perfectly fine. Now what I was saying is that we can take this and write it in a different way. This is exponential form, called exponential form because we have an exponent written here. Now, we can take it and write it in logarithmic form, which what that does is it defines the number that we are raising to powers. So in this case, we're raising 3 to some kind of power. Doesn't really matter what that power is. As long as we have this down here, we're always going to be raising 3 to some power. So we could change 4 to 5, 6, 7, 8, -2, 1/2, whatever. We could put any kind of exponent here, but no matter what, we're always going to be talking about multiplying 3's together. So like if we change this to 6, we'd be multiplying 3 times 3 times 3 times 3 times 3 times 3. We're just going to be multiplying 3's. So the base here for our log defines the number that we're counting with. It defines the number that's being raised to a power. It's what's always going to be multiplied together. Then the number that we're taking the log base 3 of is going to be what results from raising this to some power. So in this case, we raised 3 to a power and we got 81. So that's what it's saying here. We're raising 3 to some power and getting 81. And what the log does is it says, alright, if we raise 3 to the something power, we don't know, and get 81, then that power has to be 4. Okay, so logarithms help us find powers. It's the basic idea behind them. So if I instead had, x here. Okay, I don't know what power I have there now. Then this logarithm would say, alright, we have 3, we're raising it to something to get 81. Well, it gives us 4. We could plug this into a calculator or calculate it by hand if you wanted to, and it would give you 4. Okay? So again, logarithmic form takes that exponent out of the exponent place. So let me label this real quick for us. Okay. So we have exponential form and we have logarithmic form. And we can convert back and forth between these two forms depending on what we need to do. Maybe it's going to be easier to figure out in exponential form. Maybe it's going to be easier to figure out in logarithmic form. It just depends on what we need. Okay. Now, a basic way that you can remember this is with a generalized equation. So if we have y equals b to the x, this is the exponential form. We have something being raised to a power. then this can be converted to logarithmic by saying that this is log base b, because that's the thing that we're raising to powers, of y, because that was the result, equals x. Again, logarithms will be equal to whatever exponent gave us this, if this is the number that we're raising. So I'll go ahead and pause for any questions we may have. Okay, I'm not seeing any questions, so let's move on. So remember that because logarithms are based off of exponents, since we have properties for exponents, those properties actually carry over into logarithms. So let's go back over our properties of exponents real quick. So the first property that we talked about with exponents was that if we have something that we're raising to a power, let's say b, and we raise this to some power x, that we can multiply this by the same number raised to a different power, or the same power, just, a power. And what we can do with these powers is add them. So again, if we have the same number, so say this was both 2 to the x and 2 to the y, then we would multiply these and add their exponents. So this would come out to be b to the x plus y. Okay, so again, when we multiply things with powers on them, we add the powers together. So the opposite of this is dividing. So if we have two numbers that we are dividing, let's say b to the x and b to the y, then instead of adding these together, what we're going to do is we're going to subtract them. So this will give us b to the x minus y. Again, those powers subtract when we divide things that have powers on them. Okay? Another one of our properties was what happens when we raise a power to a power. Okay, so if we raise b to the x to the y power, we multiply x and y, and we get b to the xy. So again, if we raise a power to a new power, then we multiply those powers. Okay. So some other properties that we talked about. We know that b, or any number, raised to the 0 power is 1. Okay, that's just something we know. Anything raised to the 0 power will always be 1. Doesn't matter what that number is that we're raising, it's going to be 1. Okay, now I'm going to put down 2 more properties that are going to seem a little bit weird, but you'll understand why in just a minute when I start writing down properties of logs. So the first one that's a little bit weird to see right now is b to the first power is b. Which, I mean, yeah, Mr. Hardison, obviously, if you raise something to the first power, it's just itself. You're not really doing anything to it. Well, hold on. We're going to see. Second one that's a little bit weird, kind of same idea, b to the... Whoops, not h, b. b to the n is equal to b to the n. So if we raise a power, or if we raise a number to a power, we're raising that number to a power, you know? Again, seems a little weird to say it right now, but wait till we get to these properties of logs. Alright. So these are the properties of our exponential forms. Okay, so if we have something times the same number but raised to powers, we're going to take those powers and add them. If we divide two things with powers on them, we subtract. If we raise a power to a power, we multiply. If we raise something to the 0 power, it will always be 1. And these two down here, b to the 1 will always be b. And then b to any power is always going to be that same power. Okay. So let's look at the properties of logs, because properties of logs have these same properties in them. They're just written a little bit differently. Just like exponential form can be rewritten as logarithmic form. It's the same numbers and everything, it's just written a little bit differently. So let's take a look at that. Okay. So I'm going to separate this with a line right here. Ooh. Line right here. Page got away from me for a second there. So our first property of logs has to do with this property, the product property. So if we multiply two things with powers on them, we add those powers. In logarithmic form, what that says is if we take the log of a number, or a base number, and what we're taking the log of is, you know, x times y, something multiplied. Then this represents log base b of x plus log base b of y. So just like over here where we were multiplying things and then, we added the exponents, here, if we're multiplying these things inside of the log, we will add the things together as separate logs. We can separate these out as two different logs, which can be quite helpful. Alright, second one. Again, I'll separate using a line here. So this one says log base b of x divided by y. We'll do kind of the same thing. We'll separate this out into two logs, and I bet you can guess what goes between them. If multiplying got us addition, just like over here, then dividing is going to give us subtraction. Okay, so just like with our exponential property, where we divided these two and so we subtracted the exponents, over here if we divide, we're going to split it up into two different logs and subtract between them. Okay, next one. Power of a power property. What does that one translate to? Well, again, it's going to be kind of the same idea. If we have log log base b of x to the y. So we're raising a power here. Then what we can do is we can rewrite this multiplying. So remember, when we raised a power here, we multiplied those powers. Same thing. We're going to multiply the log by this power. So again, if we raise a power to a power, we multiply those powers. If we're raising a power here, we're going to multiply it by the log. Alright. So how about b to the 0? What does this one get? Okay. So what we can do with this one is we can say, all right, let's use our change of, our change of form here. So from exponential to logarithmic. If we were to change this from exponential to logarithmic, what it would say is log. Okay, remember that the b goes to the base, so b goes to the base. The result is what we're taking the log of. So 1 was our result here. And then that's equal to whatever power gave us that result, so that's 0. So what we can say then is that no matter what, if we're taking the log of base whatever, if we're taking the log of 1, it's always going to give us 0. So just like if we raised, this number to the 0 power, doesn't matter what this number is, if we raise it to the 0 power, it gives us 1. Here, in logs, it doesn't matter what our base is. If we get 1, then the exponent has to be 0. So, log of 1, no matter what the base is always going to give us 0. Okay. We can do kind of the same thing with this one. So take this one, change it from exponential to logarithmic form, what we get here is log base b, because that's what we're raising to a power, of b, because that was our result, equals 1, because that's what the power was that gave us this. So what we can see here from this property is that if we have the same base as the number that we're taking the log of, it will always equal 1. So if we have the same base as the number, it kind of cancels. So log base b of b is 1. Log base 2 of 2 is 1. Log base 500 of 500 is 1. If these two numbers match, it'll always give us 1. They are kind of going to cancel each other. Okay, and the last one down here. Okay. So, again, we can kind of take this and convert it from exponential form to logarithmic form and get something kind of interesting. If we have this, again, we can convert it to logarithmic form. Log base b, that's the thing that we're raising to a power, of, well, our result was b to the n, equals what we raised the number to, so n. Okay, so what this one says is that if we have matching log base and number, kind of like we did up here, then we're going to be left with whatever power was here, which makes sense with this one as well. Technically, the power here was 1, so yeah, it should equal 1. But that makes sense for anything then. No matter what this power is here, so in this case 1, which, yeah, that makes sense. No matter what this power is here, it's always going to be what we get out here. So again, even though these two kind of weird to put over here on this side, they make a whole lot more sense when we start talking about logs, because we're going to need to be able to cancel things out and isolate exponents and things like that. So I'm going to give us a good amount of time to write these down, and if you have any questions, please ask them. Okay, hopefully you've gotten these written down. So these are very, very important for when we're working with logs to know how these convert back and forth. So if we have something like this, we can convert it to this. If we have something like this, we can convert it to this. Okay? So knowing how to convert back and forth between the expanded form and the compact form are very good skills. So let's practice that real quick. Okay. So, let me give you this. If we have log base 2 of 8x to the 4th all over 5, can we expand this out using these properties that we have up here? Sure, absolutely. We have several properties of logs going on here. You know, just right off the bat, I see some division going on. I'm seeing some exponents. I'm seeing some multiplication. I'm seeing a lot of things going on here. So, where to start? Okay. Well, first things first, again, I see that division going on. So this division here, I'd like to get rid of this fraction. I'd like to separate this out. So remember that in our properties, it says that if we have division going on like this, we can separate it out as two separate logs, where we subtract between the two. So let's do that. So if we separate this one out, we're going to get log base 2, whoops, base 2, not base b, of the top part here, 8x to the 4th, minus log base 2 of 5. Alright, so that's the first thing that we can separate out here. What else do we have going on? Well, we got rid of that fraction. We don't have division going on anymore. We do have multiplication going on in this one, though. So if we look back up here, our product property says that if we are multiplying two things inside of a log like this, like we are here, this is 8 times x to the 4th, then we can separate them out with addition. So let's separate them out, and I'll put it on a new line down here. So this will now be log base 2 of 8, whoops, plus log base 2 of x to the 4th. And then we still have this minus log base 2 of 5, so let's go ahead and drop that down. Okay, so we've got some separation going on here. Is there anything else that we can do? Yeah! We have a power here, and so going back up to our properties, we see that if we have something with a power on it like this, x to the y, we can take this power and multiply the log by it. So I'll write it on a new line down here. So this is still log base 2 of 8, nothing going on with that one. This one, however, like we said, it has a power on it, this power 4. So we can take this power 4 and drop it in the front, multiplying by that log. So plus 4 times the log base 2 of x. And again, nothing's going on with negative log base 2 of 5, so we'll drop that one down. Okay. Is there anything else that we could do? Actually, if you got a keen eye, there is. Now, for the most part, once you get down to this might be something that I would want for an answer on a test. But for extra credit points, I would let you do something extra. And that it has to do with this 8 over here. So remember that our bases are all 2's. This right here is technically a power of 2. 8 is 2 to the third, so we can rewrite this as 2 to the third instead of just 8. So let's do that. So this is log base 2 of 2 to the third power plus 4 times the log base 2 of x minus log base 2 of 5. That's a weird looking 5. Okay. So because we have rewritten this as a power instead of just as 8, if we would go back up here, yeah, we could write it like that, but there's something else that we could do. This one right here comes into play. Remember that if we have the same base as the log that we're taking of, the number that we're taking the log of, that it leaves us with whatever power is here. So, the base matches the number we're taking the log of, so we can cancel that out and we're just left with the power, which is 3. So, we now have 3 plus 4 times the log base 2 of x minus log base 2 of 5. And there we go. So by expanding this thing out, we were actually able to get part of it kind of solved, break it down, and we were able to take this number out, and actually this is in a form now that if this was equal to something, so if we had this equal to something making this an equation, we could probably solve for x. A lot easier than if it was all tied up in this one log here. Okay, so again, I will pause for any questions we may have. Okay. So, alright, ooh, my screen's going a little bit weird. So we can take logs and expand them out. So can we go the opposite direction? Can we take something that's expanded out like this and condense it? Absolutely we can. And let's go ahead and try that out. So let's start with something that's already expanded out, it's big, and we can try to put it down to a smaller size. So let's do 3 log, so that's 3 times log, base 2 of x minus 4 times the log base 2 of x plus 3 plus 2, log base 2 of y. Okay. So what can we do here to start to condense this thing? Alright, well, let's see. What properties do we have here? I see subtraction, which means we're going to have some division going on. I also see some addition, so that's going to be multiplication. I've also got these numbers out in front of my logs here, so those are going to be exponents. So, what do we need to do first? Well, it's kind of the reverse of what we did up here. We started by separating out along the division and then the multiplication, and then we put our powers out in front. We're going to do the opposite now. We're going to start with those powers and put them back on our numbers. So, for instance, here we have 3 log base 2 of x. We're going to change that into log base 2 of x to the third. So that power goes from the front back onto its number. Same thing here, though. We have 4 times the log base 2 of x plus 3. So we're going to take 4 and stick it back onto x plus 3. Now remember, it's got to multiply by all of x plus 3. Or it's going to have to raise all of x plus 3. Not just the 3 and not just the x. So when we do this one, we're going to do log base 2 of x plus 3. But we're going to have to put this thing in parentheses again. So that we can raise the entire thing. And then we've got plus log base 2 of y. Okay. So we've gotten our powers taken care of. They're back in their respective places. What can we do now? Okay. Well, some things that I see, we have division and we have addition. So remember that those represent, we have subtraction, we have addition. So those represent division and multiplication. So we can go ahead and take these and put them together. However, there's some ordering things going on here. We'll see that in a minute when we start working with this. So right now, we have these two. This one's going to be divided by this. So because we have subtraction between these two, we're going to take this one and divide it by this one. So we'll have x to the third divided by x plus 3 to the fourth plus log base 2 of y. Now, why didn't I do these two instead? Why didn't I multiply these two together instead? Obviously, because they have addition between them, we could do that, right? Not quite. Remember that this represents division, which is going to put these two into a fraction, and it comes first. So I would rather make this into a fraction, get these their division going on before I start multiplying anything with this one. So that's what I was talking about with ordering. We really want to do the division here first. So now we can go ahead and take this one and multiply it into here. And remember that when we do that, we're going to be multiplying this as if this is over 1. So we're going to be multiplying the tops, in other words. So x to the third times y will give us x to the third y, or however you want to order it. Typically we put x first because it comes first in alphabetical order. So we'll have log base 2 of x to the third y all over x plus 3 to the fourth. And that looks like about all we can do. I think this one is as condensed as we can get it. So I will pause for any questions we have. Okay, I don't see any questions. And in that case, I have some sad news for us. This is our last class together. Tomorrow is University Dead Day, so Mr. Mrzinski won't be teaching, and Friday is the first day of finals. Now, check with your instructors, because of this whole weird distance learning thing that we're all having to do. They might have specific instructions, days, and times that you will be taking your final exam. Me, for instance, I would like to give our final exam on Monday, the 4th. Okay? So, let me just actually check real quick. Is that doable? Yeah, that looks fine. Alright, yeah, so I would like to give mine Monday, May the 4th. May the 4th. Okay? And we're going to do it like the previous test that we took. I'm going to have you sign a confidence agreement. Just tell me that you're not going to cheat. And then don't cheat. Alright? And I will have that test posted on Hawks. And so you'll be able to take that test, and it will automatically turn a grade into me. You'll have all day to do it. You just need to turn it in by midnight that day. And Hawks will give you 2 hours. I think that's all the most we're going to need is 2 hours. That'll probably be more than we need for the test I'm going to give, though. Okay? So remember, Mr. Mrzinski, he's going to give his final exam on May the 6th, and it'll be the same way that I do mine. It'll be turned in at midnight. Now, however, I do want to make an exam review. That'll be due the same day as the final, but I'm going to be trying to post that maybe tomorrow. So get that review done and, study, make sure that everything's good. And we will do our best on that exam. Okay? So, that is unfortunately all I have for that. However, this channel will have some future. So I've been streaming on it, and I've been posting all of these videos on here. But the university would actually like to continue using this channel. So there's going to be more videos posted on here, probably from me. I'd like to post some more videos on here and get some more content up. But the university might also be posting their own content. So do subscribe, continue to be subscribed to this channel. There's more to come. And if you want to learn more about math, this will be a great way to do so. Other than that, though, that is all I have for you. I will be emailing everybody some more information about the exams, and I hope you do very well on all of your exams. I hope everybody passes and has a great summer. All right? So, I'll see you later, and have a good one.